Okay, 5.6, more transformations of the sine curve. So just putting it all together today. So you remember sine curve starts at the axis. It goes up to the max for your second point, comes back down to the axis for your third point, hits the minimum on your fourth point, and then meets back up at the axis for your fifth point. Okay, so that's one wavelength of the sine curve, and we're using the 5 main points to graph it. You want to draw a box around that amplitude and period, and then kind of fit in your 5 points. So example 1, we're going to state the transformations. You want to go from left to right. So the first thing is that 3. So the 3 tells you that there is a vertical stretch by a factor of 3. The 90 degrees, it's in a bracket, so think opposite. It's going to move your whole curve left, because it's plus, so left 90 degrees. And then that -1 in the end is going to shift it down 1 unit. Okay, so those are the 3 transformations. And then to graph it, we're going to first draw a box around the period and that amplitude. So remember that there's an amplitude of 3. That's the first number there. So it's going to go as high as 3 and as low as -3. So I'm going to make a box, and then the period is 360 degrees. So I'm going to draw in my box here. I know that there's a shift, but we're not going to do that until later, right? So there is a left and a down, but we do that last. So draw in your axis, right? Actually, no, we're going to leave it like this. It's in the middle. We'll do it the highlighter. So you're going to make your 5 points. So it starts at the beginning here, finishes at 360. Halfway between it also hits the axis. Okay, so those are my 3 points. And then between the first and second one, it hits the max. So there's a point at the top. Between the last 2, you're going to hit the minimum. So there's a point at the bottom. And then that's kind of our basic shape, right? So it's going to look like up, and it goes down, and then back up. But this one has a left 90 degrees and a down 1. So I'm not going to put in my curve yet. Okay, so I'm going to move each point now left 90 degrees and down 1 to get my new like proper graph. So left 90, so if you look at the scale, it's going to be 3 boxes, and then down 1. So I'm going to move over to 90 and then down 1. So here's my new dot. So each dot I'm going to move left 90 degrees down 1, left 90 degrees down 1, left 90 down 1, left 90 down 1, and then I'm going to use my little X's to create my new graph. Okay, so the new one is going to curve up, go back down here, go to the minimum, and then back up. So it moves outside of your original yellow box, and that is totally fine. Okay, so I'm going to also mark my axis here. So that would be a line at y equals -1. Okay, so the first graph is done. Second one here, let's read it again. So the half is the amplitude, so that's going to be a vertical compression, because it's a half. Compression. It's going to be smaller by a factor of half. And then that -45 is going to go the opposite way, right? So it's going to move it right 45 degrees. And then the +1 is going to shift the whole graph up 1 unit. Okay, so I'm going to draw my box around the amplitude and the period first. So it's going to finish at 360. And it's going to be kind of tiny, this one, right? So it's only an amplitude of half. So it's only going to go halfway up and then halfway below as well. So it's a very narrow sine curve. I'm going to put my 5 dots in, right? So starting with beginning, middle, and end on the axis. Halfway between, it's going to hit the max. And then halfway between that, it's going to hit the minimum. And then now I'm going to do my move. So it's going to go right 45 degrees and up 1. So each dot, right 45, so that's kind of like 1.5 boxes, right 45, and then up 1 unit. So I'm going to go up here. That's my new dot. Second dot, right 45 degrees. That's like 1.5 boxes. And then up 1. So it's still kind of halfway there. The third dot, right 45, up 1. Sorry, right 45, up 1. The 271 is going to go right 45, up 1. And then the last one, right 45, up 1. You could also graph your axis in first if that's helpful, so you don't mess up from there. So there's my y equals +1. Okay, and then we're going to just connect the curve here. So it's going to go up, and it's going to go down to the minimum, and then back up to the axis. Okay, so it's much more squished, it's more compressed, and then it's also shifted up. So here's the graphing summary. To sketch a transform graph using the 5 main points, draw your period and amplitude with a box around it. Divide your period by 4. So you can locate your 5 main points, label your horizontal axis. You're going to sketch 1 cycle of the base curve. I just put the dots in, use the 5 main points to get a good shape, and then you're going to do the period shift, vertical shift, move it left, right, or up, down. Okay, so we'll do one more here. This one has 2 sine minus 60 minus 1. So we're going to use the amplitude of 2. Okay, and we know it's going to last 360 for the period. So it's going to go as high as 2, go down to 360. So it's going to go down to -2. So I'm just going to box in my original. And then I'm going to put our 5 dots in. So remember, beginning, middle, and end. Halfway between the first 2, I'm going to hit the max. Halfway between the last 2, it's going to hit the minimum. So I guess that's kind of like the 4 regions, right? It's kind of 4, if you look at it as regions, that's why it says 4, but really it's 5 dots. Okay, so with these dots now, we're going to do the move. So this one is going to go right 60 degrees and down 1. So each dot, I'm going to go right 60, so that's like 2 units, down 1, just watch the scale, right 60, down 1, right 60, down 1, each dot right 60, down 1, right 60 degrees, down 1. So there's my new curve. You can put in your axis, so this one is going to go across at -1, and then you're going to curve it up. Go down to the axis, goes down to the minimum, and then back up to the middle. So there's your new curve. Example 3, write the equation of the sinusoidal function, so the sine function, with a phase shift of 15 degrees right with a horizontal axis along y equals 6. Okay, so it's going to be a sine function, so y equals, doesn't say that there's any adjustment to the amplitude, so ignore that, so just start with sine. It's going to move 15 degrees to the right, so that'll be theta minus 15 degrees, think opposite side. And then the axis is y equals 6, so that's positive 6 at the end, plus 6. Okay, so that's your k number at the end there. Second one, there's an amplitude of 4 this time, so that's the number at the beginning. There's a shift of 121 degrees left, and looks like it's going down 7. So what does this one look like? Y equals a 4 in the beginning. There's a sine. Left, opposite way, so think plus 121 degrees. And then your y number is -7, so that just goes at the end. So that's the other equation. And this last one here, it's kind of going backwards. It wants us to write the sine equation. So I have to find kind of the beginning and end of this one, right? So sine starts at the axis. I can see that the middle is right at 0. Okay, so my start would be here. It goes up, down, and then back up. So there's my original sine. Let's start with the amplitude. it's the distance between the middle and the top, so that would be 2, right? So your A is equal to 2. So I can start with that. So it's going to be y equals 2 sine. It does look like it moved right here, right? So it moved right 30 degrees. I'm just going to write that down. It looks like it moved right 30 degrees. So in the bracket, you would do theta right 30. So it'll be minus 30 degrees, close bracket. And does it look like it went up or down? Nope, because the amplitude is even from that middle line, 0. So that's your final equation, 2 sine theta minus 30. Okay, so there's some textbook questions for you to practice, and then there's extra help at lunch and after school.